So we've still got a few more people on the RSVP list. We'll just wait a little bit more time. In the meantime, I'd like to welcome everyone to the World Polishing and Submission Workshop. So this is a really important workshop for you guys to know. Um, you know, when you guys submit your world, you guys want to make sure it gets submitted in the best possible state it's in. You don't want that situation to happen where like you press play and then it doesn't work. So all your hard work is gone to waste, right? So this workshop, we're gonna go through exactly what it means to polish your world, and how to submit the world in the best possible state it can be. All right. So this workshop we have Carter, Mondel, and John, who's going to be bringing you guys through what it's all about. I'm going to take a back seat, so I'll be listening in on this as well. As they're speaking, um, do type any questions that you have in the main chat right there. All right. We'll have a small Q&A session at the end after John, Mondel, and Carter have finished, and we'll address all your questions. Yeah, that we see on the chat. If you're a little bit shy to ask your questions on the main chat, feel free to like privately message me if you want, and then I'll relay your questions on your behalf. All right. So with that, Karamondo John, the floor is
Yeah,
yours.
awesome. I'll take it off from here. Like David said, we're going to be talking about world polishing and how we can kind of optimize your world, make it look prettier, and all sorts of stuff related to that. So let's go ahead and get started. First, we're going to talk about visual fidelity, um, and then we're going to talk about some assets optimization and some other additional tips you may have. So let's talk about actually making it look pretty first. As you guys may know, asset creation and actually putting together your world is one of the trickiest steps. You're going to need a lot of art assets, right? So one of the first things we recommend, if you want to make your own assets, is we have a thing called Pro Builder within Unity. It's a part of Unity, so anybody can kind of install this package and use it right away. It's easy to learn. It's very easy to prototype world out, as you can kind of see this example image here. It's very easy to install. All you have to do is go within Unity. There's a package manager, and like a couple of other things, you just have to install it, and it's completely free, which makes it a very great starting place. This is something that you would more model just kind of basic shapes with, but it gets the job done for a lot of people. And then next, if you're kind of feeling like you want to go a little bit beyond that, the next step we recommend is going further with Blender. This is kind of a more expansive program. It's not just like Pro Builder within Unity. You have to actually install it, set it up, and kind of learn all of its shortcuts, everything like that. But there are like an unlimited amount of possibilities that you can do with Blender. You can model game assets, you can animate, you can texture things. It's got a mountain of possibilities, mountains of tutorials, which is also very huge if you want to learn it. There's tons of resources on YouTube. Um, Blender, they like to actually make animations with their own programs to make sure it's very user friendly. There's tons of helpful tools available. You can install plugins, you can write scripts for Blender, and it's completely free and open to the public. So absolutely anybody can use it, start learning, and model some incredible stuff. And then next, we have free assets. These you don't even have to create. We have our ZEPETO asset package, which you can just install. Um, and we have that on our documentation, how you can do so. And you can use this expansive list of assets to use in your project completely free. We have cities, space, a whole bunch of cool themes that you guys can go ahead and use. And then also another great asset store is the Unity Asset Store, which you can, some are paid, but there's a lot of free assets that you can download and use there. And we use that for a lot of our example projects that you'll have seen on our Notion page. And yeah, uh, next, I believe I'm going to be passing it up to Mondel.
Thank you so much for that, Carter. Yeah, like Carter was saying, please check those out. The Unity Asset Store, great place for assets. The ZEPETO Asset Package, another great place for assets. And as Carter was mentioning, if you want to make your own assets, definitely check out those 3 programs and also the Unity plugin that he was just mentioning. So I'm going to jump into talking about visual fidelity in Unity and ZEPETO and how to make your worlds basically look really nice without too much effort. So let's get into that. Let me first share my screen. Okay, so visual fidelity, what is that? That's basically just making your world much nicer to look at. So on the left here is an example of a Unity scene that's just basically using default lights. As you can see on the left, it's pretty flat. All the colors are flat. There's only really a shadow there. But if you look at it, it's really kind of hard to tell what's in the background, what's in the foreground, what's in the middle ground. Now, in the second image on the right, you can see there that there's a much better sense of depth. And how is that actually accomplished? You can actually get that pretty easily by putting down, carefully putting down point lights in good places, adjusting colors of objects. So maybe like your foreground objects, maybe they're warmer in color, and your background objects are maybe cooler in color. But also something that also helps do that automatically is some post-processing as well as environment fog. So in this image here, there's some post-processing here with ambient occlusion, which if you see the edges of things where things meet, like for example, if you look at this here where the edge of the platform is, you'll see like a dark line where objects meet. That is ambient occlusion. It basically gives like a dark shadow around objects. It kind of grounds objects to the scene. So that's a good one to use. Bloom is another good one. Basically, it gives a scene kind of a glow. And then there's also camera blur, which really helps with the depth because as you can see there, the objects in the background, those round spheres, are really pushed in the background. And the main point of that is because of the blur. And they're kind of blurrier than objects in the foreground. And then finally, the thing that has this scene also making it look like it has a lot of depth is the environment fog, which is super easy to set up. That's just in your environment settings. So another thing that's also super easy to do and adds a lot to your scene is having movement. And one of the easiest ways to add movement is by using particle systems. So let me just play this video real quick, and it's going to show you some fire particles in the scene. So as you can see there, there's the fire flame particle, the magical fire flame particle. And that just adds movement to your scene. And that combined with the bloom, like makes the fire really glow. So that also sets it apart and gives your scene more interest. So particles is definitely something that you should definitely play with. It's going to add a lot to your scene. Now, the other thing that's also great to make scenes more interesting is having animation. And one of the easiest ways of having animation is actually just to use a physics system. So here I'm going to show you just quickly a video of objects bouncing around. So this is just using basic Unity physics, and it has a bounce material on it so that it makes those objects bounce up and it doesn't stop bouncing. But you can see there, just having this kind of movement just there alone adds more to your scene as well. The other part is, as Carter was mentioning in the previous section, he was talking about getting assets from not only the asset store, but also the Unity assets themselves, or sorry, the ZEPETO assets themselves. And here you'll see that I'm using the ZEPETO assets in the scene, and I'll show you what that looks like. So if you see in the background there, that's a kind of like a temple slash castle, an Asian temple slash castle. And that can be gotten from the asset store, the ZEPETO assets package. And as you can see here, the other thing that's also making this look interesting is that the bouncing objects add interest, and then the movement of the flames also add interest. And also the other thing I just wanted to mention too real quick was that you can actually do a lot just by, if you look at here, this could be some kind of game, right? This could be some kind of obstacle avoidance game. So just by placing animated objects with physics, or either you animate them yourselves, you can actually make some pretty cool things and maybe come up with ideas. For example, there I just hit a physics object and launch it into the background. So maybe this is some kind of like game where you have to launch physics objects and you score points based on what those physics objects hit. But as you can see, just by playing around with assets with Unity physics, adding some flames, you could come up with a pretty interesting scene. Let's take a look at the next one. So we mentioned animations. The other way to make animations is actually do keyframe animations. And even things as simple as, let's say for this scene, for example, it has like a camera that looks at you. If it's just like kind of moving side to side, scanning the environment, that adds like life to your scene. But let's say, I don't know, there's like windmills in the background spinning, or clouds in the background moving, anything like that, any kind of movement. Very simple to do. It's very cheap on as far as like the CPU. It doesn't take up a lot of resources, but it just adds a lot to your scenes. Very easy to do. Definitely play around with keyframe animations. And then finally, the thing that really makes a game look polished is the UI. If you have a really good, clean UI for your start, for start of the game, while the game's playing, when the game's ending, if all those scenes have really nice UI, it's going to really add a lot of polish to your game. And for this, I would say, you can start off, you could definitely make your own UI, but you can also use the Unity Asset Store and get a bunch of free UIs. So I would play around with that. Definitely play around with the UI because it really adds a lot to the scene and makes things look much, much nicer. All right, so the next section, I'm actually going to pass it off to John. He's going to talk about optimization, a super important part of game development and getting your world ready for submission. So John, I'm going to pass it off to you.
Thank you so much, Mondul. Can I make sure my screen is visible? Can everybody see my screen right now?
I just stopped sharing, John. Maybe it was because I didn't stop sharing in time. Can you try again?
Sure, sure. How's that look?
Yep, I think I see it.
Okay, perfect, perfect. So thank you so much, Mondul. Yeah, those are going to be really awesome tips for you guys, especially since you guys are in the like the beginning development stages, figuring out where to get your art assets, how to make things look pretty, things like that. Hopefully, some of these tips will help you guys kind of speed along the process a little bit, because I mean, like Mondul mentions, there's a lot of areas that you can just quickly add different things to your scene to make it look pretty really fast. But now that, I mean, let's say that, you're starting to finish the development and you're gonna start thinking about how to make it fast. I'm gonna teach you guys exactly what things might slow down your world as you start developing. So we're gonna talk about a couple tips first. So like if as good as your world might be, if your world doesn't run well, if it's really slow, all of the stuff that all of these ideas that you've put into it that you wish people can get to and really enjoy, they won't be able to properly enjoy it if it doesn't run well on your machine or on the devices that the people are playing. So first, what is optimization in the first place? So it's just the ability to run on the lowest target device that you're targeting. So in the case of ZEPETO, that's going to be I believe it's the iPhone 8. Um, and I'll go into like what the minimum spec devices are, but you're gonna have to make sure that your game is running on the lowest spec device, and keeping what those values are in mind as you kind of start developing your world. So it's good to have a general understanding of this stuff as you start developing, so that you kind of have in mind what to optimize later on. So we're gonna be removing some CPU bound, so coding optimization, and then GPU bound, which is graphic stuff. Um, but before we get into that, I want to highlight very, very strongly that you should not be prematurely optimizing. So don't worry about how fast your world runs in the very beginning. The goal is going to be for you to get to a working prototype as soon as possible. So all of the layers of your world, get that in, and don't worry at all about how fast it runs. And just make sure that everything's functional first, and then worry about optimization after that. because if you're spending so much time, invested into optimization, and then you end up not finishing your world, that's going to be that's going to be even worse. So make sure you get your world done before you get into optimization. So again, optimize last. Don't spend so much of your of your time budget working on optimization. Make sure that you get your full core loop done. And then number two, utilize the profiler. The profiler, I'm going to show you guys what that is, but that's going to be where you can see the different statistics of what is eating up the most amount of time in both CPU and GPU bound kind of code and rendering tasks. So we actually did a project. It was kind of like a quiz game where you run through the portals, and then your goal is just to get to the end as soon as you can. So then we had created this game, created this world on ZEPETO, and we really quickly got this world together, and I think in about a week or so. So we really rushed through this project just to get something working to verify that this is a fun game to actually to play. And you can kind of see the batches here. These numbers aren't going to really make sense to you right now because I haven't told you what are good numbers and what are bad. But I can tell you that these are very, very bad numbers. 4,000 batches and 1.3 million tries are going to be very, very bad numbers. But again, in our first pass of this world, we weren't worried at all about optimization. We just wanted to get something functional. We wanted to get something working so that if we need to toss this world because we don't feel that this is this is good, then we can make that decision before we spend too much time into it. Once we did verify, hey, this is something that we do want to pursue, we think this is going to be fun, then we went into, adding the polished environmental assets and worrying about optimization and making sure all of those assets are properly optimized before adding it into the world and things like that. And you can kind of see the difference here. We're getting about 95 batches and 67 K tries. And in a world that looks, it looks pretty polished. It looks pretty dense. But we're still getting close to under 100K in batches and under 100 batches on 100K tries. So some general notes for ZEPETO specifically. ZEPETO preloads resources used into in the world into memory. So basically, all of the resources that you're using in your world, it kind of loads them into memory. So make sure that inside of your resources folder, you're minimizing that. If you're using resource.load at all, make sure that those are kind of minimized because that will add to the total memory usage in your world. So keep that at a minimum. Number two, the minimum spec devices that I mentioned on iPhone is going to be iPhone 8, which has about 2 gigabytes of RAM, and Galaxy S8, which has about 4 gigabytes of RAM. So that means that if you want your world to run properly on all devices, you're going to want to target 2 gigabytes of RAM. Okay, so make sure that the total usage of all your assets in your world don't exceed 2 gigabytes. Actually, also keep in mind that the ZEPETO avatar is also very, very heavy. So if you have a world that has a very high player count, keep that in mind as well. That the more players you have, the less the less frames you might get in your world. So the maximum frame limit on ZEPETO, worlds that run on ZEPETO is going to be 30 FPS, and the package capacity is going to be limited to 1 gigabyte. So when you're creating your final package, and we're going to go over this in the future about exactly what you do before you can submit it, but basically you're going to be generating this file that you're going to submit onto the ZEPETO portal. When you do that, you have to make sure that that package file isn't exceeding 1 gigabyte. Okay, so the stats window is going to be the quickest way to kind of verify what your values are in your world. So you saw earlier, this stats window for the quiz game. That's going to be where you're going to verify exactly how much resources that your world is currently eating up. So, in this case, it's 30 batches and 6.5K tries. But keep an eye on that. Keep an eye, number one, on the frame rate. It's going to be the frame rate isn't really going to matter too much because you're on your desktop or Mac, right? Which is going to be a lot faster than what the device is actually able to render. But if your frame rate goes below 30 on your desktop, that's reason to assume that it's probably not going to run so well on your device. So just keep that number in mind. Make sure that it's at 30 FPS, and then your batches and tries are relatively low. So speaking of your poly count, so your tries, um, you're gonna want to make sure that the number is close to 100K as possible. So you saw that before it was up to 1.3 million, right? And again, don't worry about this number until you actually start, optimizing. But keep that number as close to 100K if possible. But I mean, it's going to be a lot more of a task for you if in the beginning you have all of these assets that you now have to optimize and replace. So it could be a good idea to kind of keep an eye on this number as you start developing your world so that it doesn't get so high. But yeah, keep that under 100K if possible. Under 300K is still fine. It's gonna run relatively. It's gonna run reasonably, but do not exceed 500K if you can help it. Try to keep it under 500K. If you need to remove assets from your world, just remove things out of the scene. Like if you have a bunch of trees everywhere, kind of maybe decrease that a little bit. But just make sure that your total poly count is under 500K. Again, for the draw calls, you're going to keep it under 100. That's going to be the best if it's under 100. But 250, kind of more on the higher end, and then no more than 500. So keep that in mind. So draw calls, I actually didn't go into too much detail of what this exactly is. But draw calls is basically the number of kind of passes that your graphics card on your phone or on your graphics chip on your phone or your desktop has to do before rendering a single frame to your display, right? So then if it has to render this object first and then another object, so it's going to render everything in layers before it can finally render that to your monitor. So in order to reduce this number, you have to make sure that your graphics card is rendering doing as little passes together. So that's what batching is, so that we make sure that we're grouping objects together and tell the GPU to draw this at the same time instead of drawing this separately. And that's going to happen mostly from your materials and your textures. So if your objects in your world are sharing the same texture and the same material, then that is when the GPU kind of will say, okay, everything that uses this material and this texture, I'm going to draw those all together at the same time. So that's going to be the best way to make sure that you're optimizing your materials, optimizing that draw call number. Try to keep all of the environmental assets using the same material and texture. The frame debugger is going to be a useful tool to kind of step through exactly in a single frame. What are the layers that my graphics card is kind of? What are the steps that it's taking to render that frame? So then this is going to be your draw call number, right? So if the draw call is like 500, then you're going to see 500 steps. There's like a little slider up at the top that you can kind of slide through and see all of the different steps. From 0 all the way to 500, you're going to see exactly what is being rendered, and the texture it's using, the material it's using, the shader that the material is using, all of that stuff is going to be available to you as information. So this is going to be a good thing to kind of keep in mind. To use the frame debugger, when you start kind of seeing exactly what is being rendered at each step, and how many steps it's taking to render a single frame. And I mentioned the profiler earlier, but this is going to be the most useful tool to kind of see what things are eating up the most GPU time to render. What's taking the longest to render, and what's taking the most, CPU time, like your code. Like if you have very, very unreasonably like optimized code, instead of a bunch of kind of green here, you're gonna see a bunch of blue. In this particular screenshot, I have disabled everything but the rendering, so everything is just green. But if I enabled scripts, you're also gonna see like blue lines in here, and if your blue lines are really high, then that's gonna mean that your scripts are very unoptimized. And if you kind of click to a very specific time, right? Like if you click to maybe you see a spike up, in this profiler. If you click on that spike, it'll tell you what is taking up so much time in that specific time point in time. So you can kind of see, okay, these objects are taking up the most time, or this function is taking up so much time. I should optimize that. So the profiler is going to be a very good tool for you to kind of look at as you start your optimizing steps. Use GPU instancing. So a lot of materials are going to have the option to use GPU instancing, and basically, what this means that it can render multiple copies of a mesh with the same material in a single draw call. So if you have maybe certain materials that are certain meshes that are using the same kind of material but different meshes, right? What GPU instancing will be able to do is it'll kind of group those meshes together into a single draw call. So that's going to be very useful. Take a look at this video tutorial link to kind of look at this in more detail. But this is going to be useful. It's a very easy way to save some draw calls as well. Next is camera occlusion culling. So this is something that I actually learned recently as well, but this is very, very cool. Your camera, when you're looking in a certain direction, it naturally kind of culls things that are outside of the view frustum, right? Like whatever the camera is looking at, right? So you can kind of see by these white lines what the camera is currently, what's visible to the camera. But it renders everything regardless of whether your camera can actually see it or not, right? If it's pointing in that direction, it's always going to render it. What occlusion culling will do is it'll kind of shoot rays out of your camera. Basically, it'll shoot lines from your camera and see if it hits objects. Whatever those rays hit will be rendered. So what this means is that if your camera is maybe in a room, right? So if you kind of see this chunk, that's the room, and then there's walls blocking that space, then everything behind that wall isn't going to be rendered. So basically, it only renders things that the camera can actually see. So this is going to be, it's another very easy way to do it. It's so easy to set up. You just kind of set up this occlusion culling box, and then you can easily kind of occlude objects behind the camera. So this is going to be useful for maybe for you guys that are maybe in first person perspective, or really close to the character, where your camera may not see things behind other objects. So occlusion culling, a good way to save some draw calls. This is going to be a very, very important one. So if you have multiple cameras in your scene, make sure that you're only rendering a single camera at a time. So by default, I believe that there is a camera that exists in the ZEPETO scene. If you create a new scene and then you kind of spawn the player in, that initial camera is going to be rendering as well. So make sure that you delete that camera. So just all this to say, just make sure that in any part that's running in your world, make sure that there's only one camera that's running. If there is a case where you need to run multiple cameras, like for example, you see this kind of CCTV like on this TV here, right? That's another camera that's currently rendering. But a way that maybe you can optimize this is that maybe if the character is turning away from it, if that TV isn't in view, to disable that camera. So there's things that you can do to optimize things that, like if you have to have a camera that's visible, then you have to kind of write some code to kind of minimize that as much as possible. But number of cameras is going to be a common mistake where it basically doubles your draw calls and doubles your poly counts because it's rendering 2 times on 2 different cameras. Even if that camera isn't active, um, the other camera is still rendering and still kind of making calculations. So make sure you only have a single camera. These are some additional tips. So what I've explained so far are kind of really easy ways that you can do, easy kind of optimization tips that you can make kind of towards the end of your development cycle. But these are some additional tips that maybe you guys probably won't have the capacity or the bandwidth to do in this World Jam, but I wanted to get this information out there for maybe those of you that maybe have strong artists in your team that understand optimization or have the capacity to maybe create custom art, things like that. These are going to be some tips that are going to be useful for you guys. So number 1 is vertex animation textures. So if you kind of think about animations, right? If let's say that I'm animating my arm, right? Most kind of humanoid animations, they have bones, right? So then when you're animating, you're basically animating the different kind of joints, right? So if I'm saying hi, then if I kind of move my hand, then like my arm joint, my shoulder joint, my elbow, all of that stuff is moving along with it. Those extra calculations is what makes bone animations a lot more expensive to do. So then if you have a lot of kind of characters in your scene that are using these bone animations, that's going to add a lot more to your add so much to the performance. So instead, what you can do is you can use vertex animation textures. And basically, this is just a texture that has a bunch of animation data baked into the texture. It sounds kind of odd, but then there's a way to kind of bake animation frames, animation data into a texture, and then have a shader tell the object how to move, so that it can kind of create the animations. So this is a very, very cool thing. For example, like if you see this book here, right? Books aren't gonna run by bones, right? I can't imagine bones inside of a book. But then if you use vertex animation textures, you can bake that into the texture and then tell the shader to kind of animate this. Then it's so much more cost efficient to use vertex animation textures if you don't need to use bones. So yeah, this is going to be a good way. You can look into this video and see if it's possible for you guys to implement. But if this is maybe out of your reach at the moment, maybe keep this in mind for the future, and try to learn exactly how this works. Next is going to be texture atlasing. So if you have different UI elements, and this is probably most commonly used for UI, but if you have a single texture for every single UI element in your scene, then that's going to be a separate draw call for all of those UI, right? I mentioned that to save draw calls, you have to have the same material and the same texture. That's for all of your objects. If you have different individual UI, like you have a button, and then you have another kind of you have a pause button here and like another button up here. If you have separate textures, that's going to be a separate draw call. What texture atlasing will do is basically you can kind of combine everything into a single texture, and then you can kind of say, okay, this button, I want to use this piece of the texture. This button, I want to use this piece of the texture. This image, I want to use this piece of the texture. So you can kind of group everything into a single texture and then therefore save so much draw calls to kind of bunch everything into one texture and then use a technique called atlasing to kind of select which part of the texture that you want to use. So another very, very cool thing that you can do. Again, this is going to require a lot of independent study on your part. It's not as easy as like the other stuff that I mentioned maybe in the first half of this optimization. That's very simple stuff you can do. It's just a setting that you can just set up. These are going to require a lot more extra kind of steps on your part. Next is optimizing shaders. So one important thing to keep in mind is that transparent objects are very are expensive in any game. And the reason for this is if you imagine how transparency works, is that an object has a color, right? If you have some block, right, this pink block here, it has a color, right? But in order to make transparency work, I have to know what's behind the object, and then mix the color behind this object into the original color of my object, right? So it takes a second pass, and therefore doubling your draw calls, and it's a lot more expensive to use transparency in your materials and than it is to use opaque, right? Solid colors, right? So then if you can avoid it, try to kind of go through all of the materials that are used in your world. Make sure to kind of call out everything that's using transparency, and then make sure all of those are opaque, because transparency is very, very expensive in your game. A technique to kind of avoid that is a technique called dithering. So basically, what this does is you can kind of see that this character is behind this transparent kind of box, right? But this box is actually not transparent at all. What's happening is that it's poking holes in the mesh, right? So that you can kind of see through it. And that's what dithering shader does. It kind of pokes hole into the mesh and then makes those holes bigger and bigger so that it looks more and more transparent. So that's a technique. Maybe you can find a shader that uses this and then import that in. If you're interested in dithering, and you can kind of take a look at the site link here to get more information on it. But dithering is going to be a good way to kind of circumvent the fact that transparency is not going to be the most ideal in your world. So avoid transparency if possible. Use dithering. Use dithering if you can. Next is some camera culling masks. So if you have certain kind of special shaders, let's say for example you have like a pool, right? If you have a pool that's reflecting objects in your scene, right? If you look into the pool, you can see like a second copy of everything that is reflecting. If you kind of use layers, then you can kind of make sure that that pool is only rendering certain objects that are assigned to different layers. So I can assign a layer, I can assign different layers to different objects. So then if there's a pool, then I can mark certain layers to say, okay, these layers I want to reflect in the pool. Everything else is not important. I don't want to render those. So then the pool is going to render less objects because you kind of set your shader up to ignore those layers. So this is going to require like a very specific instance. If you have special shaders that are kind of reflecting everything, then you can kind of call different things, different objects, so that it ignores things on those layers, so that it's using less calculation. So again, this is probably not going to be super relevant to you guys unless you have a shader that, or you guys are using a shader that's expensive, that you can kind of use this technique to kind of only render certain layers. And that's actually the end of my presentation. Um, with this, I will pass the mic back to David for kind of closing statements.
Sorry, hey guys. Thanks, John, Mondul, and Carter for that excellent workshop on how to polish your world and how to make sure you submit your world in the best state it can be. That was a lot of information. I know a lot of you might not have caught all that at the same time. Don't worry, we have recording all our sessions, and you can find them on the participants guide. We will let you know in the announcements channel or on Discord when it's uploaded, so you can take your time and absorb everything. So, like I said, any questions that you guys might have, now's the time to ask. With about like 5 minutes, like drawn out just for you guys to ask any questions you might have. Um, yeah, feel free, shoot, guys. So there was actually a question on, is there a link to the Vertex animation tutorial? Looks like Steph has already sent the link. Thanks, Steph. Yeah, I hope that helps. All right. Questions. If there is no questions, I think we can call it for today then. Um, Once again, thank you, John Mondul Carter, for that great presentation. To the everyone here, good luck. You are not right now on week three. You guys should be well in, like just about past the brainstorming stage and going on to the scripting. Um, so I hope this workshop has been really helpful with regards to making sure your board looks pretty, visual fidelity, making sure you got sorted all the kinks. So great, thanks everyone. That's it for today.